So for today's video, we are going to discuss the network layer protocols, chapter 6 on Cisco NetAcad, just all the figures and some of terminologies for clarifications of its use. The exchange of data. The data will be sent, segment, it will become segment, it will become packet, it will become frame, then it will become a bit, then routing. So on this figure, we can see that addressing end device must be on the routing table, and the encapsulation is it will encapsulate as its order on its order and de-encapsulate on reverse of its order. Like the application, the data will be encapsulated to the transport, it will become a segment, and the network it will become a packet, and on the data it will become a frame, and the physical it will become bits. It will go into a it will go to the routers. So then after that it will be de-encapsulated. It will become a frame, it will become a packet, it will become a packet, it will become a segment, and it will become a data. Then encapsulation, after that routing. The network layer provides services to direct packet to its destination host on network. So the address will be packet by the router to for it to um for it to transport to the host. Then the encapsulation when the packet arrives to the network, the host check the IP address, header, and all of the things to until it becomes a data. So next, network layer protocols. There are two network layer protocols, the IPv4 and IPv6. Okay, next. Encapsulating IP. So here, as we can see, there's a segment here on the transport layer. So the figure 2, the transport layer encapsulation will now become a data for the network layer encapsulation, which it will put an IP header on the front of the segment header data. So now it will going to become a packet, IP packet. The network layer adds a header so the packets can be routed through complex networks and reach their destination. Okay. Oops. Characteristics of IP. Characteristics of IP are connectionless, best effort, and media independent. Connectionless is it doesn't need a complete connection between the sender and the receiver to sending data before sending data packets. The best effort is IP is inherently unreliable because packet delivery is not guaranteed. It's not sure if the packet is were not dropped during the process or it will reach the what do you call the host. And media independent is operation dependent of the medium, copper, fiber, optic, or wireless carrying data. Next is IP connectionless, as what I have said, the sender doesn't know to if the receiver is present, if the message is arrived, and the receiver can accept the letter. Then the receiver doesn't know when it's coming. Hindi niya alam kung kailan darating yung message. Then the best effort, it is not sure that during the process the all of the packets were able to reach its destination. And on the media independent, it can travel over different medias. So it doesn't so it means that the all of the media like LAN, WAN, and wireless, it can travel through all of them. Then next is packet header. IPv4 packet header composed of 20 bytes, and it composed of a version which the value set is 0100, then differentiated services or deep serve, which is formerly called TOS or type of service, and it has an 8-bit field, and to determine the priority of each packets. Kung anong priority ng packets, yun lang yung determine niya. Then the time to live is amount of um the amount what how can I say that? The the hops of the packet on every route. For example, the packet will will pass through the first router, and it has a two two hops, or time to live, two lifetime. Then now it's already one, and if the packet will hop to the other remote network, then it will be decremented by the hop will be decremented by one, and the packet will drop. The protocol is identify the next level protocol. The source IP, a 32-bit, um, is the source of the message, and the destination is the recipient of the message. It contains also 32-bit. Next, limitations of IPv4. IPv4 depletion. There's a limited there now on our generation. There is now a limited unique public IPv4 address available. Although there's 4 billion, but on our generation there's a lot of people that uses different computers that have and intermediary devices that have set that has different unique IPv4 addresses. Internet routing table expansion, a routing table used by a router to make best path determination. As the number of servers connected to the internet increases, so too does the number of network of routes. So lumalaki din yung at dumadami yung gumagamit ng routing table. Then lack of end-to-end connectivity, the network address translation or not, technology used to implement within IPv4 networks. It used to para mapaunti yung paggamit ng uh, IPv4 address, yung NAT or network address translation. Then introducing IPv6. IPv6 is the best solution for the IPv4 because it has one undecillion possible unique IPv6 address than the 1 billion plus of unique IPv4 address. So the improvement is increase in address space from 32-bit. It now becomes a 128-bit, and improve in packet handling, and also eliminates the need for NAT or network address translation. Encapsulating IPv6, one of the major design of IPv6 over IPv4 is a simplified packet header. Now, this is the IPv4 header. There's too many things on the IPv4 header, but in the IPv6, there's only here. These are all the elements of the IPv6 header. Okay, the version is 0110, I guess. Okay, let's check. 0110, the version. And the traffic class is, it's like differentiated services or DS. And the flow label is receive the same type of handling the routes. The flow label. Uh, it is the responsible for handling routes. Then the payload length is indicate length of data portion, and next header is indicates data payload type that packet. And hop limit is like the TTL, which is in every hop for every remote network, the TTL, the hop limit will be decreased by 1. Then the source and the destination IPv6 address. Now let's proceed to the next, next. Host forwarding. It can forward to itself, and it can forward host to forward it itself called a loopback, and it can forward to a local host, which which the two hosts is on the same local network, and also it can forward to a remote host outside of the outside of the network. Then proceed. Default gateway. A default gateway routes traffic to other network, has a local IP address in the same address range as other hosts on the network, can take data and forward data out. The default gateway, it is an IP address also that belongs to the range of the IP address on the local network, and routes the traffic to other network. It means its IP address will be set as the default gateway of every devices on the local network, and can take data in and forward data out. Next. Okay, as what I have said earlier, all devices must use the IP address of the router as its of the port of the router as its default gateway to forward a data. Then host routing tables. Mm, the command is netstat-r. Then you will able to see active routes or route print. Next, route packet forwarding. Uh, on forwarding a packet, there's a different. For example, uh, routing table of the router can store information about what the directly connected routes and the remote routes or default route. The directly connect routes is the devices that are directly connected to the remote network, and the remote routes is the network outside the remote network. And the default route is like a host. Routers also use the default route as a last resort if there's no other route to the desired network in the routing table. Okay, next, IPv4 route and routing table. In order to see the different routes on the routing table, you will just type the command show IP route on the privilege exec mode. Then it will show you the different no the IP route. The next directly connected routing. This is the route source. It can be local interface or directly connected. This is the IP, the destination network. And how was it learned? Directly connected. It is directly connected to what port, to what outgoing interface. It is the gigabit Ethernet 0 over 0. And C identifies directly connected, and L identifies as local interface. And next, remote network routing table. This is how the routing table will be shown on the IP route. This is the destination network. This is the route source. It can either DC or other things like what I've what we've seen before. S static route, D enhanced interior gateway, EIGRP, and O open short path. Okay, this is the destination network. Identifies the destination network. Then the number 90 is the administrative distance. Identifies the administrative distance of the route source. And this is the metric. This is the next hop. Next hop address. And this is the route timestamp. Router was last heard from, and this is where the outgoing interface. Next, next hop address. The next hop address is it's like the first destination of the packet, and every hop on a remote network, it will the hop limit will be decremented by 1 until it becomes 0. And if it becomes 0, it will it will drop the frame or the packet. Next, next. A router is a computer. A router is a computer because, as we can see, routers have also OS, memory, fan, motherboard, ports, and other things that computer has, especially the NVRAM, RAM, and the ROM of a router. But the memory is not that so big. So okay, then it has a CPU built in. The router CPU is here. Then next, the router memory is RAM and RAM, flash and ROM. ROM containing the running iOS, routing table, ARP table, running configuration, and packet buffer. The NVRAM has start of configuration files, and the flash has iOS files, and the ROM has post and ROM monitor firmware. RAM is a volatile RAM is the volatile memory used Used to store application, process data, and it's executed by the CPU. But if the data doesn't is not already saved, and unfortunately there's a power loss, all of your data might lose. And the ROM is the non-volatile memory. It's used to store crucial operational instructions like this one. And next, the NVRAM is non-volatile memory used to permanent storage for startup configuration file. So if you already set up a configuration, you can save it by typing the command to the privilege exec mode. The command copy run start. So the running configuration will going to be saved at the startup configuration. Next, the flash. Flash contains the iOS files. Okay, let's proceed. Inside a router, we can see a shield for one interface, two shield for one interface, and a power supply, and a mini fan, and a SD-ROM or ROM holding running configuration, then the NVRAM and boot flash memory, and the CPU of a router, then a more advanced integration module. Connect a router. Connect a router. To connect a router, as we can see, there are two. There are auxiliary or aux. There are console ports here. Then 2 gigabit internet, a USB, and uh, enhanced high-speed WAN interface card EHWIC, and compact flash slots. But I think all of these are upgradable. You can change this or that, whether what configuration you want to add on your physical configuration on your router. Then LAN and WAN interfaces. This is the management ports, the console and AUX port. It can configure, manage, and troubleshoot your router. And this is the our LAN interface. IP addressing carry user traffic. Ethernet interfaces most common LAN connections, while common WAN connection include serial DLS interfaces. So as what I said earlier, it can interchange with other modules. Then the console, secure shell or SSH. I've already explained it to the previous chapters. Also the telnet. Then proceed to the second figure. This is the serial WAN interfaces. The EHWIC0, and these two are the Ethernet LAN interfaces, which you can connect a Ethernet keyboard. Next, bootset files. On this figure, we can see that if we start a what we call this a router, the iOS image will be copied to the RAM. It will load iOS to the RAM, and the npram will load the startup config. But if it doesn't load startup config, it will load running config. Next, router boot process. If we turn on the router, it will perform post on the ROM. Then after it perform post, it will load the bootstrap. After that, the flash will locate and load the operating system. If it doesn't see an operating system, it will open the TFTP to find. Then after that, it will find the NVRAM, and if doesn't configuration, look for TFTP server, and if can find other, it will going to initialize. You need to initialize configure the router, and it will load the running configuration. Then and it will locate and load the configuration file or enter setup mode if necessary. Okay. Okay. Next. Show the version output. Show version is the command for displaying the version of your simply display the version of your router. Then you will see the specs, and oh yeah, you will able to see the specs. Next, configure initial settings. Okay, configuring a router, a switch. This is a configured switch. Then this is a simple switch configuration, and we already learned it from the previous chapters. The next is basic router configuration is mostly like the switch configuration. You will going to create a banner, create a password for line, console, VTY, and AUX, and password for the privilege exec mode, and also to the user exec mode. Then okay, let's skip that. Configure router interfaces. This is the difference between configuring the router and the switch. On switch, you will just going to call it um configure the VLAN for the switch or IP address for the switch, and but in the router you will going to configure the 2 gigabit Ethernet interface if required, and also the serial 1 interface card. In order to configure the interfaces, you will simply type the interface on the configure terminal, the interface G gigabit Ethernet 0/0 or G 0/0, then type a IP address, then no shutdown, and also the description. Okay, here. Then, okay, verify interface configuration. To verify it, mostly we are going to type the command show IP interface brief to the privilege exec mode, because it will show us if the if the IP address is up or it is down. Then also to verify, we can ping check the IP address. So if we receive a message, so it means that it is connected. Also, we can verify IP route and interfaces and IP interfaces. And also the last T, we can save. You save it. This is the IP route on these networks. Next, default gateway for a host. Default gateway is simply the address of the port of the G0/0. The the address of this must been set by on the default gateway of the IP configuration of these two PCs, and also on this switch. By the use of default gateway, PC1 can able to verify the connectivity to PC2, and also to the connectivity to the other network, to the remote network. Next, default gateway for a switch. Tagal. Bagal ng internet. Oops. Uh, okay. I think Oh no. Okay. Uh, Technical error. The default gateway of the switch is it is switch needs also to have a called it a default gateway set to forward packets to the router. So to set a default gateway for a switch, you must go on configure terminal then type IP default dash gateway, then the default gateway 192.168.10.1. Then soon you already set a default gateway to your switch. Then next. So I think that's all for this chapter, and I hope you understand something, and I hope you learn something from me. And thank you for watching, and peace.